Okay, so this is just a quick video on the 5-figure summary, box plots and semi-interquartile range. Now, I didn't know that I definitely haven't gone over this with you, but it's very possible that Mr. Richmond might have. Really, the video is just to let you see what it is. It may or may not be asked in your exam, but if it is asked in your exam, it's something very easy to solve and we don't want to miss out on those marks. Okay, so by the end of the video, you'll know how to find the 5-figure summary for a data set, turn that 5-figure summary into a graph that we call a box plot, and calculate the semi-interquartile range for a data set. Okay, and all of that is really, really straightforward. So I'm just going to go straight in with an example. 12 college students were given a psychology test mark out of 20 for an experiment they carried out. Scores were 14, 8, 14, 11, 10, 9, 19, 16, 14, 4, 8, and 12. Find the 3 quartiles and the semi-interquartile range. Okay, so the quartiles are basically just the numbers that are going to split this data set into 4, so that you have a lower 25%, a middle lower 25%, a middle upper 25%, and an upper 25%. Okay, and that's what we want to split this data into. For that to happen, we need to rewrite this data in order. Okay, so I'm going to start with my smallest number, which I believe is 8. And I'm pretty sure I have 2 of them. So I've got 8, 8. I'll just go off as I go. Okay, so then I've got 9, 10, 11, 12, 4 14s, so 1, 2, 3, 4, 1, 2, 3, 4, 16, and the 19. Okay, so if I count up, there should be 12 there, so 2, 4, 6, 8, 10, 12, so I know that I've got all the numbers, and then now, as my starting point, what I'm going to do is split that 12 in half. So I've got 8, 8, 9, 10, 11, 12, and that's going to be my first split. Okay, and essentially, that's the median. We've got 6 on either side, so that's what we call our quartile 2, and it's going to be 13, or just so that we know we're talking about the median. Okay, and then to find quartile 1 and quartile 3, I'm going to take each of these data sets and split them down the middle again. So 8, 8, 9 for one, 10, 11, 12 for the next one. So then I'm looking at quartile 1 being 9.5. Okay, so the first quartile is 9.5, so that means the first 25% of my data is going to be less than that. The next 25% of my data is going to be between 9.5 and 13, which it is, and then now I'm going to split the next set. So I've got 3 lots of 14 and a 14, so quartile 3 is at 14, and then I've got 15, 16, and 19. And here, that's me calculated my 3 quartiles. Now the semi-interquartile range, which we're going to shorten to SIQ, is just quartile 3 minus quartile 1, and then because it's semi, means we've got to divide by 2. So 14 minus 9.5 divided by 2. So 14 minus 9.5 is 4.5. Divide that by 2, and you'll get 2.25. Semi-interquartile range is 2.25. What the semi-interquartile range does is that it measures the spread and the range of your data. So the larger that number, then the more spread out your data is. Okay, much like standard deviation measures spread of data, so does your semi-interquartile range. Okay, and it's less cumbersome calculation-wise to be able to work out the semi-interquartile range. Okay, so I said on the first page that we were going to be looking at what we call the 5-figure summary, the quartile, sorry, so quartile 1, 2, and 3. They are 3 parts of your 5-figure summary, and the next example is going to take us through how you get the other 2 and create your box plot. So a father timed how long his daughter was on the phone during 10 phone calls over a 2-night period, and here are the time in minutes. Okay, and I was nice to you this time, and I put them in order. So we've got 2, 5, 6, 8, 10, 10, 10, 12, 17, and 22. First part of the question is asking us to find the median and the upper and lower quartiles. So I want quartile 1, quartile 2, and quartile 3. Okay, so that's what I know what I'm looking for. Okay, these are 10 phone calls, so if I'm splitting it in half, I'm going to get 5 and 5. So we're straight down the middle here. 5 on one side, 5 on the other, so quartile 2 is 10 minutes. Okay, because halfway between 10 and 10 is just 10. Quartile 1 is going to be the lower end, and this time we've got 5, so if we're going to split it in half, then we're taking 6 as our quartile. Okay, so basically you're finding the median. Once you've found the median, you're going to keep going with that. So quartile 1 is 6, and doing the same up again at the top, we're going to get that quartile 3 is 12. So like I said, those are 3 figures from our 5-figure summary. The other 2 figures are the maximum and the minimum. So if I get my line tool, I can show you how we construct our box plot. So I'm going to put a line at the minimum, which is 2. And obviously you're going to do this much neater than me. Select, okay, so I want to straighten that and move it more to the 2. So this is not playing ball at all, I apologise. Right, there's the 2. Right, let's get rid of that. Right, I want to delete that bit I just got holding onto there. How do I do that? So let's use the drop down. There we go. Okay, right, so put a mark at 2, then get my line tool back again and stick another mark at 22. And obviously again you're going to do this much neater than me, and you should be a wee bit further off the graph than mine is currently. Again, we're going to delete that. I don't know why it's creating all these extra shapes. Okay, right, so 22. Let's shorten this one. Okay, right, we've marked in those. Okay, right, and now we're going to mark in our quartiles. Where did that go? Come back. Okay, so back to our line tool, marking our quartiles. So we've got one at 6, one at 10, and one at 12. Okay, and then to create a box plot, all I'm going to do is connect the 3 quartiles so that they make a box, and connect onto the upper and lower values to create a box. And please make sure that yours is a lot neater than this. And hopefully what you can see now really clearly, what you're seeing now really clearly is that you've got this box thing that in the US they call it a box and whisker plot, and we call it a box plot. And you're seeing that box, and what it's showing you really clearly is that the majority of your data is at the lower end of the spectrum. You know, your first 75% really are less than 12, and there's only the top 25% that going to be above 12, so you can see that really clearly from the diagram, so it makes it a really valuable diagram for understanding the spread of your data. Okay, so the next thing to look at is the semi-interquartile range. Okay, so the semi-interquartile range is obviously quartile 3 minus quartile 1 divided by 2. So if I get my pen tool, so semi-interquartile range is going to be 12, 12 minus 6 divided by 2. Well, 12 minus 6 is 6 divided by 2 is 3. So my semi-interquartile range is 3. So what that's suggesting is that there's quite a significant gap between all of my data. It's not as compact and as combined as I would like it to be. Okay, so I was going to give you another example to work through, but I think I will just leave you to do this on yourself. Okay, so the daily rainfall in millimeters was measured on the roof of the meteorological offices from March 10th to March 23rd. Again, these are not in order, so you'll need to rearrange them and find the median and quartiles, show the results as a box plot, and calculate the semi-interquartile range. And then another example for you to do, the number of visits to the dentist in the last year by the members of a hockey club were as follows. Find the quartiles and construct a box plot, calculate the semi-interquartile range. And again, clearly, hopefully, you can see that that's not in order, so your first step is going to have to be to rearrange that. Okay, but let's just go back and evaluate and see where we're at. So we do now know how to find the 5-figure summary for the data set. We need to find the lowest value, the highest value, and the 3 quartiles. Hopefully we can see clearly how you turn a 5-figure summary into a box plot. This part is unlikely to be assessed. What is likely to be assessed if you're asked about it in the exam is to calculate the semi-interquartile range for a data set. So this skill and this skill are going to be needed, definitely needed. Okay, but hopefully covered everything, and if you have any questions, just let me know.